Greetings for everyone. Today we are going to presentate about linear system in real words like science and technology. So let me introduce myself. My name is Nathaniel. My student ID is DSC2509116.
And my name is Jonathan Wijaya. My student ID is DSC2509119.
Okay. So the purpose of this presentation is explores how we take these abstract lines and grids and turn them into the building we live in and tell the technology we use every day, like phones, buildings, vehicle, and everything, including bridge also. So the first thing is, what is a linear system? A linear system is essentially a collection of two or more equations that share the same variables. Think of it as a set of rows that must all be true at the same time. And the second one, it is the power of matrix form. It is AX equals to B. So A is the coefficient matrix, B is the variable, and X is the constant factor. And the third one is to find a solution means finding the specific values that satisfy equations at once. So the next question is, why is it important to our life? So it is important because it's like translating. So most of the real world problems are too messy to solve with intuition alone. Linear systems act as a translator, taking physical constraints and turning them into a language that math can solve. And also managing multivariable, it allows engineers to look at all variables at the same time rather than one by one. And efficiency, sometimes we need a perfect answer. Other times we just need one that is good enough and fast and also quick. So this is one of the applications in civil engineering. The first one is modeling forces with equations. The second one is solving with matrix method. And the third one is ensuring safety and stability to everyone.
Okay, from now on, I'm gonna take the lead. I will talk you guys about the civil engineering explanation from the linear system. So in the linear system, we got the AX equals B, right? So the equation AX equals B will be the vector B will be represented by external force that we will use in the bridge. So we have to know this before we build the bridge. Okay, so the triangle load or the W divided by unit length is gonna be shown for a numerical values for the vector B. And then in the real world, it's gonna be the vector will be the vehicles weight and like external weight from anything, and then wind pressure, even the bridge on weight. So we got now calculate all of them. So we must be good at building bridge, so the bridge not gonna go over and break down.
So the conclusion is we need to solve the math first before we build our bridge, buildings, and everything. So we got external factors like weight, pressure, and even others. So we need to ensure safety first and stability to everyone.
Okay, that's right. Okay, move on. We have an application in electrical engineering. So in the picture, we can see that there is a battery. They're gonna lead from the R1, R2, or R3 until the battery again. So for the electrical system, the vector B gonna be the voltage that come out from the battery. Okay, and the value in the E1 and the KVL or KCL equation represent a constant input that form the right hand side answer of our linear edge system and the vector b. In the real world, this represent that use of the battery to running out this electrical system. So in the conclusion, this just represent about the how to use electrical system in the real life.
Yeah, so this is the basics of electrical engineering to our real life. And the summary is the battery represents the actual power, and then supplies connected to devices like lights, everything included, Wi-Fi, and most of electrical engineering things.
And then we continue. And the last one, we're gonna applicate the linear system into the science and technology. You know that phone can zoom in and zoom out, right? Like this picture. So this is the real pictures, and then we can zoom in and zoom out like this, and like this. Okay. We're gonna use the camera to zoom in and zoom out, right? And we can also use the zoom in and zoom out in the computer and anything else. So the system gonna be so we're gonna be use metric to change the size and position of the object. The result of the transformation is the new position of the vector b. Okay, and the constant of key x and key y are the scaling factors. When we multiply the original vector, we use the k to multiply the output of the image and the input of the image, so the output gonna be different. In the real world, this is how the filters zooming in and zooming out in photos and website and anything else. We use like k to multiply or maybe divide the real pictures.
So it's like basically a filter that we use in our phone, in our iPad, every devices, Android, computer. So it's like giving us a little bit of technology inside of the photo. So you can use the filter to make it black and white, or maybe make it brighter, darker. So it's like, that is the conclusion. You can even zoom in and zoom out, cropping everything in your phone, or even like setting everything inside the photo or picture. So that's the conclusion. So the most of the presentation conclusion is the study of linear systems is vital for modern science and engineering for the following reasons. So you got future jobs also like data science, analytics, civil engineering, logistics, and more of them is connected to linear system. It's like most of our future jobs, we need mathematics people who is very smart, very intelligent, diligent, yeah, and they will help us doing the real world problems like buildings, pollution, and everything that connected to science and technology, engineering. So it's like translating reality, and it allows us to turn complex physical realities like lines and grids into the buildings and technology we lived in. For example, our dorm, which is in LY8, we need like linear algebra system and also physics knowledge. We use two of them and then combine it into one and then ensure safety and stability to everyone. The second one is multivariable management. It provides a structured way to manage and solve multiply variable simulations. And then the third one is efficiency and precision. So without mathematics, without linear algebra, and without calculus, we can't even compute everything. We need to solve everything, completely precision. That's why we need to learn linear system so it can comply the knowledge into the real worlds. And to find exact solutions to ensure stability and also the design. So this is the end of our presentation of linear system in engineering, and goodbye.
Goodbye.
See you.
That's all from us. Thank you.
Thank you.